Okay, let's look at the question. I like what Calista did here. The question, listen carefully, please. Let me just run through what she did and pick up from where she stopped. The question says a current of 4.5, this is 4.5, right?
Yes.
A current of 4.5 ampere is passed through a solution of what? Gold salts for 1 hour 45 minutes, right? Now the question now says, number one, calculate the mass of the, tell the person that she should lower her voice, please. Calculate the mass of gold deposited. B says number of moles of gold deposited. Then C said if the same current is used, find a time for 5.5, right, gram of gold to be what? Deposited. Now our current is 4.5. The time, she converted the time 1 hour 45 minutes, she multiplied by 60 minutes. 1 hour is 60 minutes, right? 60 minutes times 60 will give you 3,600 seconds, plus 45 minutes times 60 will give us 2,700 seconds. Total is 6,300 seconds. Is that clear? Now, so remember the quantity of electricity is equal to current times what? Time. So the current is 4.5 times 6,300 watts seconds. Every to give us 28,350 coulomb. That's the quantity of what? Electricity that was passed through. Now, from the cathodic equation of gold, one mole of electron will be what? Gained. True or false? In the reduction, right, one mole will be what? Gained in order for the gold to be what? Deposited. And remember I said that 1 mole of electron is certain as 1 Faraday. So that means 1 mole of electron is required to deposit 1 mole of what? Gold. So, and molar mass of gold is 197. That means 1 Faraday will deposit 197 gram of what? Gold. And 1 Faraday is 96,600 coulomb. So 96,600 coulomb is required to deposit 197 gram of what? Gold. So if 96,500 coulomb deposit 197 gram of gold, so 28,350 coulomb will deposit what? X. So we cross multiply, at the end we got 57.88 gram of gold. Don't worry. 57.88 gram of gold will be required to what? To be deposited by what? This quantity of what? Electricity. So now the second question says we should find the number of moles deposited. Remember that number of moles is molar mass over what? Molar mass. Reactive mass over what? Molar mass. So that means the mass deposited is 57.88 gram divided by what? 197 gram. Actually, the right way to do it, even though yes, this has become a formula, but simply know that molar mass, 1 mole of gold is a simple thing. Since 1 mole of gold has a mass of 1 mole of gold has a mass of what? 197 what? Gram. True or false? 1 mole of gold has a mass of 197 gram because that is the molar mass. Therefore, how many moles of gold we have? 57.88 gram. I'm telling you where this formula came from. So that means X is now equal to what? 1 mole times what? 57.88 what? Gram. All over what? 197 gram. Gram will cancel gram. Mole will remain. Divide this by this, you get what? 0.29 mole. Have you seen where it came from? It's always good to know where a formula came from, because some question they want to test your knowledge of where the formula came from, and you become confused. It came from the fact that molar mass of gold is 197 gram, which means that 1 mole of gas, 1 mole of gold has a mass of what? 197 gram. Therefore, 57.80 gram of gold will be how many moles? That's where this whole thing came from. Is it clear? Now, having solved this one, where is this thing? Having solved to this level, let's go to the C part of the question. The C part of the question says, if the same current is used, find a time taken for 5.5 gram of gold to be deposited. If the same current is used, they want to find out the time it will do what? Take. What does it mean? Remember that. Remember that cure is what? IT, right? Remember that cure is what? IT. And here now, we are told that the same current was used. Are we together? Meaning that the current is what? Constant. Is that clear? What the time required to deposit 5.5 gram will now be what? That's the question. So what say that you wanted to say.
Define the quantity.
By how?
Let me solve it.
Say it.
You use the same method now. This method.
And find the quantity.
Let me finish this now.
Calm down. Tell me what to do. Don't worry. It's something.
Oh, not like that.
Tell me what you want. The step you will take.
96,500 Faraday. You deposit 196. Then that quantity. You look for that is X. You deposit how many mass? 5.5 gram. Then you look for the quantity.
So if you don't get quantity, there's no board for you in the exam hall. Learn how to explain things with you. Even without solving it on the board. That's what I want to inculcate in you now. Nothing preventing for allow you to come here. Explain what you wanted to do. Good. She said if I got what you said right, she said that basically we know that one farad which is 96,500 coulomb deposited what? 197. So what quantity will deposit 5.5 gram? Do you understand what she's saying? So if 197, if 96,500 deposit 197, what quantity will deposit 5.5 gram? Is that clear? That's what she's trying to say. So if you follow what she said, you get something like this: that 96,500 coulomb will deposit what? 197 gram of what? Gold. So what will deposit 5.5 gram of gold? What quantity of electricity? We call it S, right? So S is now equal to what? 96,500 coulomb times what? All over what? 197 gram. What's the answer? Gram will cancel gram. What's the answer? Fast, no time. What's the answer? Punch well. 96,500 times 5.5 divided by 197.
2,000. It's not relative again.
26.
It's not.
What's going on here now?
96,500
times this is equal to, then you divide it.
That is 500.
Equal to. So whatever you get, you divide it by 197. What's the answer?
2693.
Point what?
0.9.
0.9 what coulomb? Please give me the raw figure. After the point, what about we are there?
8624.
86 column. Is that clear? You get why? Just you get why. But you know that it has options. So depending on what the option they gave you in the option. If it is one that has option. Now, this is the quantity of electricity that will deposit 5.5 grams. Remember that Q is equal to what? IT. And we are told that the time is the same, right? The time is what? The same.
No, the current.
Sorry. Thank you. The current is what? The same. But the time changed. The quantity of electricity what? Changed. So if you fix the new quantity of electricity and fix the new time, and the new current, let's see the time we'll get now. Is that clear? So if you fix the new quantity of electricity, which is what? 2693 point what? 86 coulomb is equal to the current that did not change is what? 4.5 ampere times what? Time. That means that the time is now 2963.86 coulomb times what?
So I will put my 2693.
You say what?
2693.
Hey, thank you. 26. He said another thing. The 2693 point what? 86 times what? Sorry, divided by what? 4.5. 4.5. What's the answer? What's the answer?
The answer is 598.
598 point what?
0.6355.
0.63 what?
5.
I think we can leave it at 0.6, no problem. 0.6 what?
4.
Seconds. 355.
Yes.
No, we'll leave it at that. Seconds. It's 6 seconds, right? I hope you know. Yes. But you know, you can still convert this to minutes if you want, depending on how the question comes. Depending on how the questions comes. But 598. But in real sense, is that how they left it?
Yeah, they converted to minutes.
They converted to minutes. So divided by 60.
Okay, because of the question came in minutes.
It's even in hour per minute. So we can still move it to hour per minute. So it will, if you move it to hours, it will not work. So it should be minutes. If you leave it hour, it will be 0 point something hour, which is going to be so a minute. How many minutes?
9 point.
9 point what?
98.
9.9. Okay, minutes.
Divided by 60.
Now, no problem. Now, you can still get this same answer if you use, if 228 and 350 coulomb deposits 7.88 gram. Are you aware that you can get the same answer from here? Are you aware? Are you aware? You can choose to work from here. 28,350 coulomb deposits 57.88 gram of what? Gold. Therefore, 5.5 gram of gold deposited by X. Are you aware that you get some answer? Are you aware?
Yes.
You're not aware? Should we try it?
Yes,
Right, okay. Now, so if we say we have already established here that 28,350 coulomb deposit what? 197 gram, right?
Yes.
So their X will deposit what? 5.5 gram. So X is 9. Sorry, this one is for this one. Not 197. It's for 50 what?
7.88.
57 point what?
88 gram.
So S is now equal to what? 28,300 coulomb times 5.5 gram over what? 57.88 what gram. What's the answer?
The answer is 2689.
269
point
what?
18.
18. This difference is from approximations we did here. Are you there? It's from what? Approximations here. Are you there?
Yes.
So understand that. Now, 9 what? 9 what? Column, right? Now, so if remember that current quantity of reduced is equal to what? IT. So 2689.18 coulomb will give you what? Current of what?
4.5 ampere
times time. So time is equal to what? 2689.18 over what? What's the answer?
The answer is 597.5.
97 point what?
59.
0.6, right? Seconds. This is 598.6. 597.6. Come here. Punch this thing. Let me show you something now. Punch this thing. Times 197. Over 96 around 500.
That is 57.875.
57 point what?
875.
If you leave that 57.9, I bring 57.9 here now. Okay, sorry. What is the raw value, please? Rough value is what?
875.
8 what?
75.
Is that all?
Continuously.
It's okay. You know, our promotion can cause a lot of things. So now, bring this 57.875 here. Use it to divide this. 228 and 300 times 5.5 divided by 57.875.
The answer is 2689.
26 what?
2689.
Okay. Point what?
41.
Don't worry. Divided by
60.
60.
I mean, is it 4.5?
Sorry, 4.5.
5.9. 5.
Let me calm down. Let me show you something. Calm down. Let me show you. There's something I want to show. Off it. Look up. Remember that this number was not approximated. Is the actual absolute number it is.
Yes.
Now let us not approximate this number by ourselves and see what we get. Divide this.
Before that mass.
I'm coming. Divide this. It's 197.
Yeah.
Divide this. Whatever you get, don't approximate. I want to show you that these two values are the same thing. It's just approximation. That's what you get, right?
Yes.
Now, see what we do now. Yeah? How can we use this now? Okay, this will be on the see what we do now. Remember our idea, our mission. Look up. Our mission is to use what we get here to divide this one, right?
Yes.
But I don't want us to approximate it. Is it clear?
Yes.
But this thing will not help. This phone will not. This thing it cannot work because it will be deleted. So you know to avoid that now. Let me do some manipulation there. Are you aware? Look up. Are you aware that this thing is certain as saying? Are you aware that 28300 times 5.5 gram over divided by this one now? Remember, whatever we get here, this thing now give us this answer, right?
Yes.
So we can Kukuma bring everything here and put it here, right? I'll get something like this. 28350 times 197 over what?
Over
96,500. Are you aware that you can, if you invite, are you aware that 2 over 1 divided by 3 over 4? You said not saying 2 over 1 times 3 over 4.
4 over 3.
4 over 3, sorry, 4 over what? 3. Remember, are you aware? You so let's, based on that, let's invert this. This is taken as saying
division.
300 times 5.5 times what?
96,500.
Over what? Over what?
2,857 times 197.
350 times 197. Oh yeah, you cannot punch this thing now. You cannot punch. I have run away from approximation. Are you following? So punch. Just punch. That divided by that. See how you do it. See how you do it. See how you do it. Let me teach you. It's off. Okay now. See how you do it. Look up. Multiply this. Multiply this. Whatever you get, divide by this. Divide again by this. You get the answer. Is that clear? So do it sharp. I've run away from what from.
Time. Is that what you do with them? That is not easy. I'm not that.
Do you think I am doing this because of this?
Yeah?
Do you think I'm doing this?
No, what to understand?
It's not about this question. I'm trying to teach you another thing altogether. It's not about this question. You are wasting time.
Okay. 28. 28300 times 5.5. It's 96,500. That is 7,500 is equal to. Where do these people see it from?
Divide by.
When they put it there, yeah, which one is it there?
Leave that thing is exponential.
Okay.
Divided by
Divided by
350 equal to divided by again
969.197.
2689.41.
Good. That's
9 point what? 41 divided by 4.5 is what?
597.
No.
Yes, it's divided by 45.
Oh, wait. Look at what is trying to tell you. 2689.41 divided by.
No, it's not the same thing. Yeah, it's not the same thing.
What do you get?
597.64.
Same thing now.
667.
Is it clear now? Did you understand this question?
Yes,
Did
sir.
Did you?
Yes, sir.
Any other question on electrolysis?
You take, I don't know for this.
Have you seen? You said you
Am I
saw.
right?
Yes?
Am I right?
I like your
Yes.
Okay, let me look for her.
Oh yeah. The question says a given quantity of electricity was passed through 3 electrolytic cells connected in series containing solutions of silver triazonitrate 5, copper 2 tetraoxide 6 and sodium chloride respectively. If 10 grams of copper are deposited in the second electrolytic cell, calculate the mass of silver deposited in the first cell. B. volume of chlorine liberated in the third cell at 18 degrees Celsius and 740 millimeter mercury. The molar volume of the gases at STP is 22.474 dm3. Oh yeah, go and solve it fast. Wait, is this okay? I say that if you go back to the Faraday's second law of electrolysis, when the same quantity of electricity is passed through different electrolytes, so the mass deposited is inversely proportional to the charges of the ions of the substances deposited. So if that is the case now, to solve this question, first of all, ask yourself, the same quantity of electricity was passed through the three electrolytic cells. So the same quantity of electricity, but they kept the first one pending and came to the second electrolytic cell and start asking questions. They told us that 10.5 gram of copper was deposited in the second electrolytic cell. In order to solve this question, we must find the quantity of electricity that deposited at 10.5 gram. Is that quantity of electricity that deposited at 10.5 gram that is the electricity that was passed through the three electrolytes?
Okay, so look for the quantity.
Yes. So find the quantity of electricity that deposited at 10.5 gram.
So copper there is copper.
Copper we need two moles of electron. Copper will gain 2 moles of electron to be deposited as what? Copper solid. Write the cathodic equation for us first. Start from there. Good. 2 moles of electron. You now have copper solid. Good. You can now break. Right. What about that? Let it be under that 2 electron. Under that electron. Hope you understand what you're doing.
No, you have 2 Faraday with deposit. Are you okay?
Yes. Will that deposit molar mass of? Molar mass of. I following you.
They are doing it like this.
Molar mass of what? Copper. Molar mass of copper.
Of copper. Okay.
That one is for silver. 63.5 gram. Please don't always put your units. It's very important.
X
will not be equal to what? 10.5 gram. Good. 10.5 grams. So find that X. That's the quantity of electricity.
90,500 times sorry.
Keep on penny. Be working with F for now. When it's time to change, you can change.
Okay.
So X is now equal to 2 Faraday times 10.5 gram. Then, good. So punch, fast.
Okay. Is this one still be
just leave it for now. When it's time to do it, we'll do it so that we'll not start creating bogus numbers for ourselves. We'll still do it, but not now.
Zero point three three
0.337.
seven.
You have divided it.
0.070.
You have divided
33.
0.3307.
Okay. Just leave that. What?
0.331.
Yes. F for Faraday. Just leave it as F like that. So this is the quantity of electricity that was passed. Okay. See what will happen. No verse. Wait. This thing can confuse some people. But don't worry. Leave it there. Because they give it to us as here, right? Is this a jam question? Don't worry. See what happens. This F can be misunderstood for something else. When you now want to read, you will get confused. You would think it's capacitance. Just clean it, multiply it. Yes, let's do it.
To be times 96,000. Do this one times 96,500. You understand? This F is 96,500.
See what you do, because I remember that they will see read this note and become confused. No verse.
I wanted to do that. I want to say
yes, I wanted us to do, but I remember I wanted it to be easy for us. But if you leave it may confuse some people.
Am I correct? 96,500.
No. You're not correct.
97,000.
Yeah? Write it now.
96,500
Times 2. It's 193,000. 193,000. Hope you know how she got it.
Times 2.
Are you sure? Continue.
I just must feel like
Remove that F there. So the simple S is what
so punch your calculator. Punch it.
that one is column. That unit is column. Put that column there. Put column after that 193,000. Punch. So gram cannot cancel gram. You will not remain column. So what's the answer?
21,930. 1913.3.
Calm down.
31913.
31913. Point what?
3858.
Point 3. Point 3.
85.
Point 4 is okay.
385.
Yes.
We leave that.
385 is 39.
Leave that point 4.
But you said it's best to leave it in the two.
You have to leave column. It's okay like this. What next? We have gotten the quantity of electricity that passed. So this is the quantity of electricity that passed through the tray in the electric cell, because it's the same quantity of electricity that will pass. So now we can now use this one to find the first one, the mass of silver deposited. So write down the cathodic equation of silver. What happened at the cathode for silver? Silver will gain, right? Silver will gain how many electrons?
1.
Good. Write it. So we can now solve the question. So silver will get 1 electron. Ag raised to power plus here. Silver solid. Good. So one. And I say good. I like that.
You understand the same quantity we pass.
Hope you are following. You are still playing with your units. This has never dealt with you.
No, when I'm done with my answer.
Sometimes you may forget. But if it's there, you always remember it. Times 108 gram. Then over 96,500 kilo. Punch. What's the answer? Please punch correctly so we don't waste our time.
Mistake, oh.
35.716.
16 what?
551.
Gram, right?
5.7.
Gram, right?
Because that's the math. This is A.
So this is the answer to A, the first answer.
So if that one.
35.72 gram was deposited. So the second one now says calculate the volume of chlorine liberated in the third cell at 18 degrees Celsius and 740 millimeter mercury pressure. Now, they want us to calculate the volume. First of all, we should know what the mole of the. Remember in the for chlorine. Remember in the what is it called? This is a twist of what? Sodium chloride what? solution. See? That's the sodium chloride, right? So chlorine, on one chlorine atom, we gain what? We gain 1 what? We lose 1 electron, right? Right?
Yes, sir.
One chlorine atom we lose 1 electron. Chloride ion, 1 mole of chloride ion to be deposited at chlorine atom, it will lose 1 what? Electron. But chlorine will be liberated as a diatomic gas, not just 1 atom. So how many moles of electron do you think will be lost for it to be deposited? 2. So you have 2 what? 2 Faraday. Is that clear? Is that clear? So so if 2 Faraday would deposit chlorine, is that they don't give us the DC for chlorine.
There is pressure here. That pressure goes for pressure.
Okay, so what do we think we can do about this pressure now? At STP, what happened at STP? But remember that this at STP, a mole of a gas, 1 mole of gas occupies 22.4 dmq. At STP, 1 mole of gas occupies what? 22.4 gram of what? 22.4 what? 22.4 dmq volume at STP. But they don't give us anything about the molar mass of what? Chlorine. It's not their business. So what do we now do? That's the question. What do we now do? This is where the question lies. Oh yeah, let's put our group together. You don't dey run.
I go back to you.
You don't dey run.
I'm so sorry. But like, no, he said there's nothing.
Can I run the run? So can I run like this?
We have no business to do.
So can I run like this?
I'm not the one. I don't need to do past my back. I'm no good. I know. She go. I don't need to do past.
So can I abandon me?
No, I
thought we were this together.
I'm fine. I didn't do it.
You left me around.
We divided.
When you go in because stop, you're not around the organizer. Hey! These two people want me denied me for the beginning, and I was going on with you. I thought that you were with me.
I'm not the one that.
Only you will not remember. Hey! Alright,
you can do it.
Alright. Let's look at this question again. It says that we know that this 22.4 dmq means 1 mole of gas. Can I clean this, please? Please, right. So that I clean, so we can solve this one. You know that. The question, the simple thing, just are you listening?
Yes, sir.
To solve this question, they gave us something here which she pointed out. They gave us a new temperature and a new pressure, but we use this smaller volume of gas at STP. We find the volume at STP. We now move it to at this new pressure and temperature. We use this smaller volume of gas at 22.4 dmq at standard temperature and pressure. So whatever volume we will liberate at temperature, pressure and pressure, you know the answer. We will still move it to the volume at new temperature and new what? Pressure. Is it clear?
Yes, right.
So the volume I calculated as you pointed out now is the volume at what? Standard at STP. The STP means standard temperature and pressure.
Yeah.
Volume at STP is 3.7 something BMQ, which is 3,007 and something CMQ. But we want to move it at this new temperature and new pressure.
Yeah.
Is that clear? So the question now, can you solve the volume at STP? Can you solve the volume? Can you hear the question like that? Can you calculate for the volume liberated at STP? That's right.
The temperature multiplied by the pressure over the STP.
Leave pressure aside for now. Focus on the molar volume first of the gas at STP.
Use that formula now. Mole equals to over 20. That formula mole equals to over 20.
But what's the goal of chlorine?
You find it now. Use that formula. The Faraday 2 mole Faraday something. Go and do it.
I follow you. Are you sure?
Yeah, that's what I'm saying. Use Faraday 2 mole.
Oh yeah, go and solve the rest.
Mass of Faraday.
If you are following, you go and solve the rest. Then I'll.
Wait, go and try. Sorry, I don't have to.
It's not true. That's how it's Gaista. What's the Gaista? What are you doing? Alright, please. My time has elapsed, so we don't waste time here. Please look up, oh, please. I want please look up. Look up. Are we together? Now I will write we have written the cathodic reaction since. So I will write the anodic reaction. Anodic reaction now. What happens at the anode? Okay? Now at the anode, you know that the chloride ion in that solution will migrate to the anode. At the anode, copper ion, chloride ion, not chlorine, chloride ion will lose 1 mole of electron to be deposited as chlorine atom. Are we together? Chloride ion will lose 1 mole of electron to be deposited as chlorine atom. But chlorine does not hold that.
It's not supposed to be minus instead of plus. This is supposed to be.
No.
Minus and minus.
Leave that in. Leave that in, please. You know, hello? We have authorities. I am an authority. I am an authority in this.
Okay.
So give that minus.
Yes.
Once we see this, we know that it's a block of electron. Okay? Just get that one. Now, chloride ion will lose 1 electron to be deposited as chlorine atom. But chlorine does not exist as monatomic. This is diatomic. So in order to form chlorine gas is diatomic. That's why it exists as HCl2. So in order to achieve it, we have another one again. We do what? Lose. Am I communicating? To form what? Chlorine atom. So if you add everything now, we have 2 mole of chloride ion. We deposit a chlorine what? Gas by losing what? 2 mole of what? Electrons. Are we together? So this is the complete anodic reaction. 2 mole of chlorine ion will lose 2 moles of electron to deposit as what? Chlorine gas. Now, so the 2 Faraday is required for chlorine to be what? Liberated. Is it clear? So that means 2 Faraday we liberate what? Chlorine what? Gas. This one is now what? Gas. Are we together? At this level it was what? Aqueous. Here it was what? Aqueous. Are we together? But the gas cannot be formed unless two combine. That's why they are nothing here. It's just an atom. So when two combine, it becomes a gas. Is it clear? Now, 2 Faraday will liberate 1 mole. This is 1 mole of chlorine. 1 mole of what? Chlorine. As a gas, molar volume of gas at standard temperature and pressure, STP. 1 mole of a gas occupies 22.4 bm³ volume. Are we together? 1 mole of a gas occupies 22.4 bm³ volume. If we want, we can convert it to cm³ by multiplying by 1000. It becomes 2,200 watts, 40 watts, sorry, 2,400 watts. By 2,400 watts cm³. So at standard temperature and pressure, 1 mole of a gas occupies 22,400 cm³ volume. Are we together? So here now, believe you me here that 2 Faraday liberates 1 mole of chlorine gas. Do you agree with me? 1 mole. Do you agree with me? 2 Faraday will liberate 1 mole of chlorine gas. Do you agree with me? Now, then we have concluded here that at STP, at standard temperature and pressure, 1 mole of any gas, occupies what? 22.4
cm,
which is what? 2,400 what? cm³. So that means actually what it implies that wherever we see 1 mole of chlorine, we can replace it with what? 22,400 cm³. Is that clear? So that means that 2 Faraday of electricity will liberate 22,400 cm³ of what? Chlorine. Is that clear? As a what? Gas. Are we together? So the volume of gas liberated by 2 Faraday is 22,400 what? cm³. We are giving Faraday as what? 96,500. Is that clear? This implies that if you multiply it by 2, it's 193,000. Yes? That means 193,000 coulomb of electricity will liberate 22,400 cm³ of what? Chlorine what? Gas. So this whole thing is happening at STP, not at this temperature, no, but at what? STP. So if 193,000 coulomb discharges liberate 22,400 cm³ of chlorine at STP, what volume of chlorine will be liberated? Remember, it's the same quantity of electricity that passed. So what was that quantity of electricity that was passed before? We check your notes. How many thousand?
Okay, 35.72 gram.
Gram. Which is gram again?
Hold up.
Call it again.
35.72.
No.
So it's not that one. It's 31913.4. So I write it like 31913.4.
3 what?
31913.
Point what? You are acting as if you are not following. I follow you.
So it's the same quantity that will pass both the anion and cation.
All these things, we only have three electrolytes, 3 electrolytic cells. It's going to put of it that past 2-3 of them. Is that clear? So if 193,000 coulomb of electricity, I follow you. Deposit, liberate 22,400 cube of chlorine. 31,913.4 coulomb of electricity will now liberate what? We don't know, we call it what? X. So X is now equal to what? 31913.4 coulomb times 22,400 what? cm cube. All over what? 193,000. What's the answer? Coulomb will cancel coulomb. What's the answer? Punch fast.
3703.938.
3 what?
703.938.
0.938 cm cube, right? Approximately what? 3704 what? cm cube. Are you following me?
Yes.
Are you following me?
Yes.
So 3,000 704 cm cube of oxygen is liberated. Sorry, just thank you. Of chlorine is liberated at STP. But the question wants us to find out the volume that will be liberated at these two temperature and pressure. This one is at STP, and this one is at. You wanted to find out the one that volume that will be liberated at pressure of 740 millimeter mercury and temperature of what? 18 degrees Celsius. We use gas law here now to solve this question. You know gas law now. You know gas laws. We use the law that contains pressure, temperature, and what? Volume. And that is general gas equation. Simple. We use general gas what? Equation to solve this. Can I clear? Okay. We use the general gas equation. And general gas equation, our gas equation, say that P1 over what? T1 is equal to what? P2 over what? T2. Is that clear? One of them will be at standard temperature and pressure and volume, and one will be for this new temperature and new volume. Am I communicating? Are we together? So we can let's take, since we are giving the STP, so let's take the initial ones to be for what? STP. So that means P1 is equal to what? For the equation, P1 is equal to what?
7.
No. What is standard pressure? What is standard pressure?
22.4.
Pressure in millimeter mercury, 760 millimeter. You're forgetting all these things. You don't know gas laws. You want us to jump to organic chemistry. STP. What is standard temperature? I want us to go to organic chemistry. I'm not going to organic chemistry. Our next topic is gas law. No. Next topic is gas law. I'm not going to organic chemistry. You don't know the standard temperature and pressure. I'm going to organic chemistry. Sorry, gas law. Next week, please. We'll just touch it. Brush your memory on that. Any flaw you expose, we go to that topic. That's what we do until you master all these things. That one will not take us time to cover. Okay? Now, don't worry, let me tell you. Standard pressure, we have standard pressure in millimeter mercury. But we use the one in millimeter mercury because of the millimeter mercury we are giving here. Is it clear? So standard pressure in millimeter mercury is 760 millimeter mercury. Then we are giving the volume, we have calculated the volume at this STP. Two of us as what? 3,700 what? So that means V1 is what? 3,704 what? Are you following me? Are you following? Good. Now, standard temperature is what? Standard temperature is what?
273.
God bless you. 273 Kelvin. Is that clear? Now, let's look at P2. P2 is what from the question? 7 watts? 40 millimeter mercury. Right? Then, T2 is what? From the question? 18 degrees Celsius. We convert it to Kelvin. How do we convert Celsius to Kelvin?
273 plus 18.
We add 273, right? Are you following?
Yeah.
Are you sure? Alright, so add it. You add it.
Add the point of calculation.
18 plus 273. The answer is what? That should give us 291. 2 what? 291 Kelvin. Are you following? Then the volume at this temperature and pressure, we don't know it. That's what I'm looking for. Is that clear? So we now use this. Are we to this side? Right. So continue fast. Let me clean here then. Are we together?
Yes, sir.
Now, so we have established this now. Let's make V2 the subject or the formula. So from this general gas equation, V2 is now equal to what?
V1
P1 times what? T2, right? All over what?
all over
P2 T1. You can remove this time so you don't confuse yourself. That is the same thing. All over what? Is that clear? So V2 is now equal to what? P1 is what? 760 millimeter mercury times V1 is what? 3,404 cm cube times T2 is what? 291 Kelvin over P2 is what?
740 millimeter mercury.
740 millimeter mercury times T1 is what?
273 Kelvin.
273 Kelvin. What's the answer? So Kelvin will cancel Kelvin. Millimeter will cancel millimeter. We are left with cm cube. So what's the answer? Punch it now. Let's go.
you did it. Nothing you do like.
Answer is 405.8.
4 what?
05.
Point what?
48077.
0.5 what? cm cube. Is that? Let me see what you got.
You made a mistake.
Who? Are you sure she made me?
You
Where?
made a mistake. The answer is 3055. 4055. Is it 1,000, not 100?
Let me teach you how to use the calculator. Just look at this. See what you do. Simple thing. See what you do. Punch. You want to punch? Just do 760 times 3704 times 291 divided by 740. Continue divided by 273 equal to 4054.923. So 40 what? 54 point what? 9 cm cube. It can also be 4055 cm cube depending. Is that clear? Is that clear? What they get here?
That's the answer.
40 what? 55 cm cube of what? Chlorine. gas. Is that clear?
Yes, so. I should be asking you now.